Welcome to a deep dive
Whoa.
into the utterly bizarre world of quantum mechanics.
Okay.
You've shared some really intriguing excerpts from Carlo Rovelli's book, Helgoland,
Yeah.
and it seems like you're ready to tackle some seriously big questions.
Yes.
So,
Absolute.
are you ready to kind of see the strangely beautiful interior of reality,
I am.
as Heisenberg put it?
It's going to be a wild ride for sure.
Yeah.
And even physicists 100 years later are still debating what it all means. So,
Okay, well, let's unpack this, shall we?
yeah, let's do it.
So Rovelli sets the stage in the early 20th century.
Okay.
And it was a time when physicists kind of thought they had the universe pretty much figured out.
You know that classic clockwork universe,
Yeah.
everything neatly predictable, except
Hmm.
it turns out that the atom, the very building block of matter, had a few surprises up its sleeve.
Yeah, like electrons magically jumping between orbits without traveling the space in between.
Right.
It seems completely absurd.
Yeah.
But that's what the model at the time suggested.
It really is.
And the crazy part is,
Yeah.
it somehow predicted things correctly.
Right.
It's almost as if the universe was playing a cosmic joke
Yeah, exactly.
on those early physicists.
Yeah.
So along comes this young physicist, Werner Heisenberg,
Yeah.
and he's absolutely wrestling with this problem.
Right.
Rovelli describes him on this tiny island, Helgoland,
Uh-huh.
practically driven to desperation by this.
Yeah.
Yeah.
But as they say, necessity is the mother of invention.
Right.
Heisenberg had this radical idea. What if, instead of trying to visualize the electron's path,
Yeah.
which seems impossible,
Yeah.
we focus only on what we can actually observe?
So like the light emitted when the electron jumps between those mysterious orbits.
Exactly.
It's kind of like saying,
Yeah.
okay, we can't see what's happening behind the curtain, but we can see the shadows it casts.
Precisely.
Yeah.
That's it. And that's how matrix mechanics was born. Heisenberg replaced familiar variables like position and velocity
Yeah.
with tables of numbers, matrices.
Right.
And amazingly, these matrices accurately predicted the energy levels that Bohr had proposed earlier.
So it's a bit like trading a beautiful painting for a spreadsheet.
Yes.
It might not be as visually appealing,
Right.
but the numbers don't lie.
The numbers don't lie. And
Uh-huh.
Heisenberg himself described this new understanding as seeing a strangely beautiful interior to reality.
Which does sound a bit more poetic than a spreadsheet.
It does.
But if we thought matrix mechanics was a curveball,
Okay.
wait until you hear about Erwin Schrödinger
Ah, Schrödinger.
and his wild idea.
Not only a brilliant physicist, but quite the character, too.
Yeah.
Rovelli even mentions a romantic getaway in the Alps
Really?
that supposedly fueled some of his biggest breakthroughs.
Pearls for concentration.
Oh.
A mysterious lover.
Yeah.
This guy clearly knew how to find inspiration.
He did.
But tell me more about his contribution to quantum mechanics. What was his big idea?
Well, inspired by de Broglie's suggestion that maybe matter could behave like waves,
Okay.
Schrödinger came up with his own elegant equation known as the Schrödinger equation.
Mm-hmm.
And guess what?
What?
It yielded those same energy levels of the atom that Heisenberg's matrix mechanics predicted.
So two totally different approaches.
Yeah.
One with tables of numbers and the other with waves
Oh.
led to the same answer.
Yeah.
It's like quantum mechanics was saying there's more than one way to skin a cat,
Yeah.
or perhaps more appropriately,
Yeah.
there's more than one way to describe the quantum world.
Exactly.
And then just when you thought it couldn't get any weirder, another physicist, Max Born,
right.
realized that Schrödinger's wave function, which is represented by the Greek letter psi,
Yeah.
didn't describe a physical wave, like an ocean wave.
Uh-huh.
Instead, it described a probability wave.
That's right.
Okay, wait a minute.
It's-
Probability.
yeah.
Are you saying quantum mechanics is telling us we can only predict the likelihood of something happening,
Yeah.
not what will actually happen?
That's right.
It's a bit unsettling, isn't it?
It is a shift in thinking, for sure.
Yeah.
It's like trying to predict the weather.
Okay.
We can't say for sure that it will rain tomorrow.
Right.
But we can give you the probability of rain based on the information we have.
But why is that?
Yeah.
That's a good question.
Why does probability enter the picture at all?
Way.
What's going on at the fundamental level that makes things so uncertain?
That brings us to the heart of quantum weirdness,
Okay.
the concept of superposition.
Okay.
And I think the best way to understand this is through an experiment,
Okay.
one that you, the listener, supposedly witnessed yourself.
Okay.
The double-slit experiment with photons conducted in Anton Zeilinger's lab.
Oh, you mean that experiment where photons seem to defy all logic?
Yeah.
and walk through two places at once?
That's the one.
Yeah, I still haven't fully wrapped my head around that one.
It's a classic for a reason.
Yeah.
And you're right, it perfectly demonstrates this bizarre concept of superposition.
Yep.
So picture this. We have a laser beam that we split into two paths,
Okay.
each leading to a detector.
Simple enough light travels in a straight line, so we'd expect to see those photons hitting the detectors in two neat spots, right?
Yeah, that's what you would think.
Yeah.
But here's where things get strange.
Okay.
If we block one of those paths,
Yeah.
the photons going through the other path
Yeah.
don't just land in a single spot.
Right?
They spread out almost as if they knew the other path was closed off.
And that's exactly what blew me away when I saw it.
Yeah,
It's as if each photon somehow went through both paths at once,
exactly.
even though it only went through one.
That's right.
Yeah.
And that's the mind-bending concept of superposition.
Okay.
These tiny particles can exist in multiple states at the same time.
Right.
It's not that they're going one way or the other.
Yeah.
They're somehow doing both.
So the experiment makes this abstract idea of superposition tangible.
Right.
It's not just a theoretical concept.
It's real.
Yeah. You can see it.
It's something
Yeah.
we can actually see the effects of.
Exactly.
Now I know what you're thinking.
What's that?
What does it all mean?
Yeah. That's the big question.
Does the photon really travel down both paths?
Yeah.
How is that even possible?
Right.
It's like our intuition about reality is suddenly breaking down.
And you're not alone in feeling that way.
Yeah.
To this day, physicists are still grappling with what superposition implies about the nature of reality itself.
Right.
Yeah.
Okay.
It's a big one.
Yeah, it is.
Yeah, it's true. We have all this evidence for superposition,
Right.
yet we're still left with this nagging question.
Right.
What does it actually mean?
Right.
Does the world really split every time a photon goes through a double slit?
Yeah.
Does the moon disappear when we're not looking at it?
Oh.
Like Einstein once provocatively asked.
Those are some seriously big questions.
It feels like we're stepping into the realm of philosophy here, not just physics.
And you're right, the implications of quantum mechanics go far beyond the lab.
Right.
It forces us to reconsider our basic assumptions about the nature of reality itself.
Right. Yeah.
So let's dive into some of the interpretations that have been proposed to make sense of all this.
Okay. I'm ready to have my mind blown wide open.
Okay.
Where do we start?
Let's start with the most, shall we say, imaginative interpretation.
Okay.
The many worlds interpretation.
Right.
First proposed by Hugh Everett III,
Okay.
it suggests that every time a quantum measurement is made, every time there's a choice between multiple possibilities,
Uh-huh.
the universe splits into multiple branches,
Okay.
one for each possible outcome.
So you're saying there are countless parallel universes out there.
That's the basic idea.
Okay.
Every possibility, no matter how improbable, gets its own separate universe.
So in one universe, I actually won the lottery last week.
It's possible.
While in another, I'm currently stranded on a desert island.
Yeah, perhaps.
Okay.
In one universe, the dinosaurs never went extinct.
Wow.
In another, maybe humans never evolved at all.
That's both fascinating and a bit terrifying.
It is a mind-bending concept.
But hold on.
Yeah.
Doesn't this interpretation create more problems than it solves?
Well,
I mean, how do we even know these other universes exist?
right.
And what are the implications for things like cause and effect
Yeah.
if everything that could happen is happening somewhere?
Yeah, you hit the nail on the head.
Okay.
The many worlds interpretation,
Yeah.
while captivating to the imagination,
Right.
is incredibly difficult to test experimentally.
Yeah.
It also raises profound philosophical questions about the
Yeah.
nature of identity and free will.
Yeah.
If every choice leads to a split in reality,
Right.
are we truly making choices?
Right.
Or are we just passengers on this branching timeline?
It's a mind-boggling concept for
It
sure.
really is.
So what are some of the other interpretations that try to make sense of this quantum weirdness?
Well, some physicists find the many worlds interpretation a bit too extravagant, shall we say.
Okay.
They prefer something a bit more down to earth,
Okay.
like the hidden variables interpretation.
Okay.
This view suggests that there's some underlying unseen reality that determines the outcome of quantum events.
Okay.
We just can't access it directly.
All right.
So it appears as though things are happening randomly.
So it's like saying those entangled photons in Vienna and Beijing had a secret agreement from the start.
Exactly.
Okay.
But we weren't privy to their conversation.
Right.
This interpretation was championed by physicists like David Bohm,
Okay.
who developed a detailed theory of how particles could have definite trajectories
Okay.
guided by these unseen pilot waves.
Right.
This view aims to restore a sense of determinism to the quantum world.
But doesn't assuming these hidden variables contradict
Right.
what we know about Bell's theorem? Those experiments show that quantum correlations are too strong to be explained by any local realistic theory, right?
You're absolutely right.
Okay.
Bell's theorem throws a major wrench in the hidden variables interpretation,
Okay.
at least in its simplest form.
Okay.
To accommodate Bell's results,
Right.
these hidden variables would have to be non-local, meaning
Right.
they'd have to operate instantaneously across vast distances,
Right.
seemingly violating the speed of light limit.
So it seems like we're back to square one, trying to reconcile quantum mechanics with our intuitive notions of cause and effect,
Yeah.
locality,
Right.
and a single well-defined reality.
Right.
Are there any other interpretations that avoid these pitfalls?
Well, there's one more popular interpretation we should discuss.
Okay.
The physical collapse interpretation.
Okay.
This view takes a radical approach,
Okay.
suggesting that the wave function, which describes the probabilities of different outcomes,
Right.
actually collapses to a single definite state when a measurement is made.
Hold on.
Okay.
Are we saying that reality is literally determined by the observer?
It's a head-spinning concept.
That's a bit trippy.
It is.
This interpretation implies that the act of observation,
Yeah.
of interacting with a quantum system,
Right.
somehow forces it to choose a particular state,
Yeah.
bringing it from a superposition of possibilities
Yeah.
to a single, well-defined reality.
Exactly.
But who or what qualifies as an observer in this scenario?
Yeah, that's a good question.
Does it have to be a conscious being?
Right.
Or could any measuring device trigger this collapse?
Right.
And what about the implications for the vast stretches of the universe that are seemingly unobserved?
Those are all excellent questions.
Yeah.
The physical collapse interpretation, while intriguing,
Right.
leaves many open questions.
Yeah.
It's not clear what constitutes an observation
Right.
or how the collapse process physically occurs.
Yeah.
So
It seems like each of these interpretations comes with its own set of challenges and philosophical baggage. It does.
is there any way to make sense of quantum mechanics
Well,
without resorting to these extra assumptions and baggage?
that's where Carlo Rovelli's relational interpretation comes in.
Okay.
It offers a fresh perspective
Okay.
that avoids the pitfalls of the other interpretations
Right.
by taking a step back and re-examining the very foundations of how we think about physical properties.
Okay. Now I'm really intrigued.
Okay.
Tell me more about this relational interpretation.
Okay.
How does it differ from the others?
The relational interpretation starts with a simple yet profound idea.
Okay.
Properties of objects exist only in relation to other objects, not in isolation.
Okay.
It's a shift from thinking about what something is
Okay.
to thinking about what it does in relation to other things.
So it's not about the electron having a definite position.
Exactly.
It-
But about its position relative to something else,
Yeah.
like a measuring device or another particle.
Right.
Think of it like this.
Okay.
A stone doesn't have a position all by itself.
It only has a position relative to something else,
Right.
like the ground it's sitting on or the hand that's holding it.
I'm starting to see how this could apply to the quantum world.
Yeah.
So instead of an electron having a definite position and momentum,
Right.
we think of its properties as arising from its interactions with other particles or measuring devices.
Exactly.
Okay.
And this perspective moves us away from the idea of an objective world out there
Right.
to a world built on interactions and perspectives.
Right.
What's fascinating is that this isn't some new age idea.
Right.
It's actually rooted in the insights of Heisenberg and Bohr themselves,
Right.
who emphasize the importance of the observer in defining quantum phenomena.
Okay. So far, so good.
All right.
But I'm still curious how this relational interpretation tackles those baffling correlations we see in entanglement,
Yeah.
like those photons sent to Vienna and Beijing.
Right.
How can they know to have correlated properties
Yeah.
if their properties are only defined in relation to something else?
That's where the relational interpretation truly shines.
Okay.
Remember, it says there's no single objective reality.
Right.
Instead, reality is a network of relationships.
Okay.
The photon in Vienna has a property.
Uh-huh.
Its polarization, for instance,
Oh, so-
relative to the measuring device in Vienna.
Right.
And the photon in Beijing has a property relative to the measuring device in Beijing.
So there's no spooky action at a distance because the photons aren't communicating in the traditional sense.
Exactly.
Okay.
It's not that the photons are sending signals faster than light.
Right.
It's that their properties are only concretely defined when they interact with something else within a specific context.
Right.
Their correlations are a reflection of their shared history, their
Correct.
entanglement,
Okay.
not some instantaneous communication.
Okay. I have to admit,
Okay,
this relational interpretation is starting to make sense to me.
good.
It's like the universe is a giant tapestry woven from these interconnected threads of relationships.
Beautiful analogy.
And the properties of those threads only become apparent when they're woven together, not in isolation.
It challenges us to rethink our basic assumptions about reality,
Yeah.
suggesting that it's not a collection of isolated things, but a web of interdependence and interconnectedness.
It's definitely a paradigm shift, moving from a world of things to a world of relationships.
It is.
But I'm still grappling with one question.
Okay.
If everything is defined relationally,
Yeah.
what about meaning?
That's a fascinating question.
I mean, we usually associate meaning with minds, not with particles or measuring devices.
And it leads us to a deeper exploration of the nature of information itself.
Okay.
We tend to think of information in two ways.
Okay.
The technical definition, as laid out by Claude Shannon, which is all about counting possibilities,
Okay.
and the semantic definition,
Right.
which is about the meaning we ascribe to information.
So like a computer's memory stick can hold a certain amount of information,
Right.
but the bits themselves don't mean anything on their own. It's just data until we interpret it.
Yeah, that's the technical side.
Okay.
But then there's the kind of information we usually think of,
Right.
the semantic kind, like the meaning of words,
Yeah.
or the significance of a symbol.
Right.
And what's fascinating is that evolution,
Yeah.
that grand dance of life over billions of years,
Right.
provides a physical basis for this semantic meaning to emerge.
So you're saying that meaning arises from the interplay of information and evolution.
Precisely.
Okay.
Think of a bacterium sensing glucose gradients in its environment.
Okay.
That information isn't just random data.
Right.
It's meaningful because it directly impacts the bacterium's survival.
So meaning is tied to relevance,
Yes.
to what matters for an organism's ability to thrive and reproduce.
Exactly.
Okay.
And what's really cool is that this idea connects back beautifully to quantum mechanics and the relational interpretation.
Mhm.
A world built on relationships naturally leads to a world of meaningful information, where the line between mind and matter starts to blur a little.
Okay. I'm with you so far.
Okay.
But how does all this play out in our own experience
Yeah.
as conscious beings navigating a world full of meaning?
Well, imagine you're looking at a butterfly,
Okay.
admiring the vibrant colors of its wings.
Okay.
From my perspective, a relation is established between you and the butterfly.
Okay.
You're now entangled, even if the butterfly flies away.
Right.
If I ask you later what color you saw,
Yeah.
and I happen to see the same butterfly,
Oh.
our answers will match,
Okay.
even though the color only became definite when you observed it.
So it's like the act of observation creates a shared reality,
Precisely.
a kind of intersubjectivity that allows us to agree on what we're seeing.
Exactly.
Yeah.
And this shared reality built on correlations and entanglement
Right.
forms the basis of our everyday experience.
Yeah.
All the information we have about the world ultimately comes from these relationships and interactions.
It's like we're all part of this grand cosmic dance,
I like that.
constantly exchanging information and creating meaning through our interactions.
A beautiful way to put it.
Yeah.
And this relational perspective opens up new ways of thinking about some of the deepest mysteries of existence, like the nature of consciousness itself.
Okay, now you've really piqued my curiosity.
Oh, okay, good.
So are you saying that quantum mechanics could help us understand how consciousness emerges from the physical world?
It's a big question.
That's a pretty bold claim.
It is, but
Yeah.
think about it.
Yeah.
If we move away from the idea of an objective world out there
Right.
and embrace a world built on relationships,
Right.
it becomes easier to see how the subjective experience of consciousness could arise from the complex interplay of those relationships,
Right.
especially within the intricate network of our brains.
So instead of viewing consciousness as something separate from the material world,
Right.
we can see it as a natural consequence of the way matter interacts and relates,
It's
especially in highly complex systems like
Yeah.
living organisms.
And this perspective helps dissolve that artificial barrier we've erected between mind and matter.
Yeah.
It allows us to see both as different aspects of the same underlying reality,
Right.
a reality woven from relationships, information, and meaning.
Wow, that's a profound thought.
It is.
And it really underscores how quantum mechanics isn't just about obscure equations and weird experiments.
Yeah.
It's about reshaping our entire understanding of the universe and our place in it.
Absolutely.
It's been an incredible journey exploring these mind-bending ideas with you.
It has.
Quantum mechanics truly is a revolution in thought.
It is.
And Rovelli's Helgoland offers such a compelling and accessible guide to this strange and beautiful landscape.
It does.
We've covered so much from the history of quantum mechanics to those mind-boggling interpretations, and finally landing on this fascinating relational interpretation.
Yeah.
It's given us a lot to ponder about the nature of reality, the meaning of information, and even the emergence of consciousness.
It's a lot to wrap your head around, for sure.
It is.
And if this deep dive has left you with more questions than answers, that's a good thing.
Yeah.
The real adventure lies in continuing to explore these questions,
Right.
in embracing the mystery and wonder of a universe that's far more complex and interconnected than we ever thought possible.
You know, after this deep dive, I can't help but wonder if reality is this web of correlations, this dynamic interplay of relationships. Could that be the key to understanding how consciousness itself emerges?
That's a great question.
It's a tantalizing thought, and one that I'm sure will keep us all pondering the mysteries of the quantum world for a long time to come.
I think so.
Until next time, keep exploring, keep questioning, and keep diving deep.